Okay, so in this video, we are diving into a very powerful concept in finance, the future value of an ordinary annuity. Okay, imagine this. So you're regularly saving money, maybe every month or every quarter, and that money is earning interest along that way. So over time, your contributions and the accumulated interest grows into something much bigger. So that's exactly what an ordinary annuity helps us model. So an ordinary annuity means you're making regular payment at the end of each period, like at end of every month or every quarter. So to find the future value of an ordinary annuity, we use this formula over here. So here S represents the future value. That means the total amount you'll have in the account at the end of the period, and R represents the regular payment that you have to make at the end of each period. And here I represents the interest rate per period. So to get interest rate per period, what we usually do is, if we have the annual interest, which is R, and K is the number of compounding periods per year, to get the interest rate per period, we divide R by K, and n represents the total number of periods. So to get the total number of periods, we usually multiply t by k. T is the total number of years and k is the number of compounding periods per year. So this formula shows how both your contributions and the interest earned on those contributions work together to grow your investments over time. So the longer you invest and the more frequently you contribute, the more future value increases, especially with compound interest doing its job behind the scene. Okay, so now let's try some examples. Okay, so here example number 1. So here you have to find the future value of an ordinary annuity. So let's read the problem together. So you have to find the 5-year future value of an ordinary annuity with a contribution of $500 per quarter into an account that pays 8% per year compounded quarterly. So let's try to jot down the details given in this problem. So here we have $500 is being contributed every quarterly. So is contributed every quarter, and this happens for 5 years. And also the interest per year is 8%. So here R is 8%, and this is compounded quarterly. Let me write that as well. So this is going to compound quarterly. So we have to use this formula over here to get the future value. So in order to use this formula, we need to figure out these values. First of all, let's try to get my R. R is the regular payment per quarter, that is $500. And then we need I. So to get I, we need to divide R by K. So in this problem, R is the 8%. So usually you have to write your R in decimal, that is the annual interest rate. So this number is equals to 0.08 divided by K is actually here K is 4. It's because this is compounded quarterly. So here K is equals to 4 because this is compounded quarterly. Okay, so to get I, you have to divide 0.08 by 4, which will give you 0.02. And then you need N as well. So N is the total number of periods. To get total number of period, you have to multiply K by T. So K is 4 and T is the total time. in years, which is 5. If you multiply the two numbers together, you'll get 20. So now we have all the variables. Now you have to plug those numbers into this formula to get the future value. So here S means you have to plug these numbers. So I'm going to take this over here and I'm going to plug these numbers. So it's, okay, I missed 500. So this is 500 times 1 plus I, which is 0.02, to the power 20 minus 1 divided by 0.02. So you have to simplify this expression. You can use your calculator. Then you'll get your S as 12,148.68. So that means the future value of this investment is $12,148.68. So let me complete the problem. So we can write thus the future value of this investment is $12,148.68. Now let's move into the second example. Okay, so in the second example, again we have to find the future value of an ordinary annuity. So let's read this together. So Harry deposits $1,200 at the end of each month into an account that pays 12% interest per year. Okay, so that means in this problem R is equals to $200 and the interest rate per year is 12%, which means R is equals to 0.12 because this is the interest per year, which is R, not I. And then let's read further. So this is compounded monthly. So that means your K value is equals to 12. So you have to find the future value for every 4 months up to 36 months. Okay, so let's try this problem. First of all, let's try to get my I. So I is the interest rate per the period. So to get that, you have to divide R by K. So you have to divide 0.12 by 12. That will give you 0.01. So let me rewrite my formula. So if you plug this I value and R value, you'll get your formula as 200 multiplied by 1 plus I, which is 0.01 to the power n minus 1 divided by 0.01 to the, yeah, that's all. Let me simplify this a little bit. So I'm gonna add these two numbers together. Okay, I'm gonna add these two numbers together. That's all I'm gonna do here. So it's going to be 1.01 to the power n minus 1 over 0.01. Okay, so this expression gives you the future value with this information. Okay, so here remember n represents the number of months at the checkpoint. Okay, so now let's try to create a table for future values. Okay, so let me create a table. So let me take the values like this. So first column gives you the months, which is n. And then let me write here the formula. And here you'll have your future value, which is S. Okay, so now let's try first with 4 months. So you have to calculate the future values starting with 4 months up to 36 months. So with 4, you have to plug 4 into this formula to get the future value. So 200 multiplied by 1.01 to the power 4 minus 1 divided by 0.01. So this formula will give you the future value at the end of 4 months. So that is exactly $1,812.08. Moving on, next let's calculate the future value at the end of 8 months. So to get that value, you have to substitute 8 into your n. So that's going to be this. So if you use your calculator to evaluate this value, it's going to be $1,651 and also 58 cents. Okay, so likewise, you can do all the months up to 36. So I have a table over here. So this table represents all the future values corresponds to these months. And also here I have sketched the graph as well. So this is the function with taking n as the x values and s as the output. Okay, so if you study this table, you can see that each value shows that how Henry's savings grow, not just because of the monthly deposits, but because each deposits earn compound interest over time. So every small regular deposits can grow significantly when interest is compounded monthly. And the longer you save, the more powerful the effect becomes.